In this exercise, I will guide you through the process for creating a computational attractor system using a distance logic. As you can see by this Watch 3D node, the radii of different circles are changing based on its relationship to an attractor point. First, I'm going to create a new home workspace document to clear out my canvas. I am now going to find the XYZ grid component. This will allow me to very quickly create a grid of points. I'm going to use number components to control the inputs of the XYZ grid. I'm going to specify a number of 15 for the X and Y count inputs. I'm then going to copy and paste my number and specify 1 for the Z count. This will allow me to create a two-dimensional grid along the X and Y axis. For the origin of the grid, I'm just going to use 0 for X0, Y0, and Z0. I'm going to copy and paste the number component one more time and use this to control the X, Y, and Z spacing. I'm going to use an XYZ spacing of 5. After creating my XYZ grid, I'm going to preview the grid using the Watch 3D component. Here I can clearly see a grid of points spaced by 5 units. I'm going to decrease the number of grid points and increase them again to test that that parameter is working. Now that I have my grid set up, I need to create a single point in space which will act as my attractor. I'm going to find the XYZ component. I'm going to use number sliders to control the positioning of this XYZ point. I'm going to set the top constraint of my slider to 50. I'm going to copy and paste my number slider so I have one slider that controls the X position and one slider to control the Y position of the point. Finally, I'm going to use a number to control the Z input. Here I'm going to leave Z0 since it's just going to exist on the two-dimensional plane. I now want to compute the distance between the XYZ point and every point on the XYZ grid. To visualize this relationship, I'm going to create a line component on my canvas. I will use the XYZ grid as the start point and the single point for the end point. When I connect my line component into the Watch 3D component, I can see that there is now a line connecting the single XYZ point and every point along my grid. However, while this is a good visualization technique, what I really want are the distance values between my single point and the grid of points. I'm going to search for the XYZ distance component. This will allow me to measure the distance between my single point and the grid of points. I will connect my XYZ grid in for the A input and the single XYZ in for the B input. I can use a watch component to see how the distances are being computed. After I have my distances computed, I can use these distances to control some geometry. I'm going to search for the circle component. The center of the circle is going to be my XYZ grid. The radius of the circle, for now I can create a number component. By specifying a single number into the circle component, that radius of the circle will be applied to all circles on the grid. I'm going to connect my circle input into the Watch 3D component. When I zoom in, you can see that I have multiple circles being created at every point. For visualization, I can increase the radii of the circles. Instead of a single radius, however, I want each of the circles to respond to the distance relationship. I'm going to disconnect my single radius and connect in my XYZ distances into the radius input of the circle component. What this will have done is we'll have created a series of circles on the XYZ grid. The radius of each circle will correspond to the distance that circle is from the point. While this effect might seem pretty cool, it's actually not quite what I'm looking for yet. I actually want to scale the distance values so I have a more controlled list of circle radii. I'm going to find the mathematical divide component. I'm going to connect my list of XYZ distances into the first input of divide. I'm now going to divide them by a single number. I'm going to pick a value of 30. This means that I'm going to divide each of the distances by a value of 30 using the divide component. We can see the results of that division by connecting the divide component into our watch component. All the values have now been scaled. I'm going to now connect the divide component into the circle radius component. Now you can clearly see that each of the circles have a different radius. If I decrease the amount of division, the circles will either grow larger or smaller. If I now move the sliders that control my XYZ position of the attractor point, you can see that the overall system now responds to the position of that point, and the radius of the circles will change. I have several options for how I can visualize the result in the Watch 3D component. If I right-click on the circle and uncheck Preview Upstream, the Watch 3D will only preview the circle geometry. The point geometry which exists downstream will no longer be represented in the Watch 3D component. I can now continue to manipulate the X, Y, and Z positions of my attractor point. This will allow me to continue to study variations in my attractor system.